Mansfield is the manager for American Hawaii Water Company's operations in Hawaii, and he hosted EAH and guests at the Hawaii Kai Wastewater Treatment Plant on Friday, August 16, 2024. Lee has over 40 years of operational and design experience in the water and wastewater industry in Hawaii, Guam, and other Pacific islands. Lee is a past president of EAH. Prior to the plant tour, Lee briefed the group on the plant wastewater flow in terms of 4 surrogates: grit, golf balls, coffee grinds plus Crisco, that is vegetable oil, and sugar. Using the plant flow schematic, he clearly explained the grit and screening operations at the headworks, the biological treatment, the primary and final clarifiers, the final UV disinfection, and the ocean outfall. Lee also explained the sludge treatment stabilization in the primary and secondary digesters, and the screw presses, which discharge the plant's treated sludge for transport to H-Power, Honolulu's garbage-to-energy plant. Lee then led the group on the plant tour by following the wastewater flow through the plant as depicted on the plant schematic. He pointed out each treatment process and answered the group's questions. He also provided many insights into the proper operation of the plant in the community. Overall, Lee was successful in explaining the plant's operations to both technical and non-technical guests.
Okay, hello, and everybody. This is a wonderful special meeting of engineers and architects of Hawaii. Friday, August 16th. Thank you all for joining us. It's quite a beautiful looking group from here. Okay, do we have any guests today? Any specific guests?
We have Matt Lasecki joining us. He's a Hawaii American Waters engineer. He's been involved in almost all the project improvements here at the plant. He's back in the park. He's waving right now.
Welcome.
He lives in LA.
Okay, welcome. Okay, is there any particular announcement?
Board of Directors meeting tomorrow, Walkerley Country Club, for those that are coming.
Thanks so much to Lee for getting this tour together. So I guess I'll turn the program over to Lee.
Okay, want to welcome everybody, whether you're joining in person or online. Welcome to our plant. We are in the process of bringing a plant that was parts of which were built in the 60s up to the standards of today and serve the Hawaii Kai community. Made a presentation a few weeks ago. I showed our service area, and basically if your zip code is 96825, you're one of our customers. Thank you for that contribution every other month. I appreciate that. And so we also treat wastewater. The city collects in their own system in Kuli'o Valley and Paioko. And just to make life interesting, there's a couple streets of city customers in Port Lock surrounded by Hawaii American customers and a very interesting plumbing. So I'm going to start with a schematic of our treatment plant. It is if you're a wastewater person, this plant's a traditional secondary treatment plant using a very well-established process of activated sludge, which is bacteria that require oxygen, and they do the work here, much of the work here at the plant. When I give these tours to non-engineering people, I ask them to think of 4 surrogates for the characteristics of the material we treat at this plant. And those surrogates are grit. It's inert, it's heavy, it settles fast. Golf balls, they're large. If they get caught in any machinery, they can cause problems. I also use a hybrid. Think about, you take your coffee grinds and you mix it a little bit of Crisco in. That's a surrogate to what happens in the primary treatment process. And the last surrogate is sugar. Sugar dissolves in water, and that's what we remove in the secondary. So as I move through the process, I'll remind you of those 4 surrogates. Finally, the last thing we do we disinfect the effluent before it goes out into the ocean. It's discharged about a quarter-mile off a sandy beach at a depth of about 40 to 50 feet deep. We just had divers run the outfall. We visually inspect the outfall every 5 years as required in our permit. So Henry Kaiser built this plant when he envisioned a second planned community in Hawaii. Story is he came out to help a friend in Port Lock, and at this vision, he just this is a perfect place. He ran to Bishop Estate, got the lease, built the plant. He was never able, although his successor companies wanted to have the city take over the facility. That never happened for two reasons. The city didn't like these pump stations that were steel cans in the ground with the pumps 30, 40 feet down. Number one, they didn't want anything to do with that. They had them, and they failed on the city with regularity. The other thing is the city thought the owner, I think it was Kemper Insurance at that time, the owner of this utility should should pay the city, actually pay the city to take the facility. So eventually American Water purchased this in 1997. I came on staff in late 2001, and Matt has been very active in upgrading a lot of the unit operations and processes here. All right, so remember that first surrogate, sand? That's one of the first processes. It's just a simple sedimentary process. Let the water still, the grit, and basically it is sand. It's more than a surrogate. It probably actually is what we're removing. Heavy inorganic material removed. Then we move to a screen. That's where the golf balls are removed. And reason is we don't want large material continuing into our plant to get clogs, forming clogs or damaging equipment. Following the grit removal, we have our primary clarifier. That's where the Crisco coated coffee grinds are removed. Think of the coffee grinds, so they're organic, they're biodegradable, and they're slightly more dense than water. They'll settle. They settle in these large rectangular tanks where the Crisco will rise to the surface, it being lighter than water. So those two, that surrogate is removed in the primary. I mentioned about the sugar. Oh, first, let me jump here. I mentioned about the sugar, dissolved organic material that's removed. It's consumed by aerobic bacteria. They convert that hydrocarbon to carbon dioxide and water. In doing so, they reproduce and they produce an excess amount of biosolids. So the what we call mixed liquor is the mixture of our wastewater and the microorganisms, and that flows out of these biological reactors into a clarifier, again a stilling tank to allow material heavier than water to settle. That's where we remove the bacteria because we need to return it to the process. We return about 90% of the material to the aeration tank, and we dewater. We thicken up about 10% of the mass and move that to another biological process, which I'll talk about in a minute. We also have what's termed an Anoxic Zone. This is an area, a channel, where we mix the bacteria with the effluent from the primary clarifiers. And the idea here is to do a little bit of nutrient removal. We oxidize ammonia in the secondary system. That converts it to nitrate, nitrite. And what we're trying to do in the Anoxic Zone is have the special group of bacteria consume nitrate, nitrite, and converting that to nitrogen gas, and thereby removing some of the nutrients present in the wastewater. So again, it's the sand removed initially, the golf balls in the screens, the material that's organic and settles or floats removed in the primary process, the dissolved sugar removed in the biological reactors with aerobic bacteria. And then, well, we've got to process a couple sludge streams. And we use another biological process, anaerobic digestion, or for a layperson, it's basically a fermentation process. It takes place with bacteria that don't require oxygen for metabolism. We take our sludge from the primary clarifiers and we pump it directly into the digesters. There's two large tanks. They operate in series, a primary and a secondary unit. Again, a biological process. The objective is to reduce the amount of sludge produced by this plant. We also take that waste microorganism, that waste biomass. We thicken it on a press. I'll show you the press and the tour. We get it to more like a consistency of pudding, and we pump that also combined with the primary sludge. We introduce that into our primary digester. It spends about 15 days there in digestion and moves to the secondary unit. These tanks are identical. Retention time about 30 days. We remove sludge from these fermenters, these anaerobic digesters, and we go to we go to a dewatering process, which here at this plant is a screw press. We basically squeeze the water out of a sludge, and then that material is pretty much like a solid, and then that's sent to the H-Power facility, trucked out of here with roll-off bins. I'll get back to the effluent. We do the separation between the treated water and the bacteria in the final clarifiers. The bacteria sent on its way, which we've discussed. Now the clarified water exits the final clarifiers, and then it runs through a UV disinfection process. And the idea here is that we want to reduce the concentration of pathogenic bacteria prior to ocean disposal. So we run this water close by sets of ultraviolet light, not any different than what we have here, except these have a coating to not allow the UV light to exit. Our system here allows the UV light to exit the bulb, and this basically messes up the ability of pathogenic bacteria to reproduce, and also does some effective kill of pathogenic bacteria and any other bacteria present. But again, the target with disinfection is the pathogenic or disease-causing bacteria. Then again, we go out our outfall, a quarter of a mile out, 40 to 50 feet in depth, discharge through several diffusers into a flowing ocean current. Yeah, that's the trestle that was built to build the outfall.
Oh, wow. Oh, interesting. Why did they need a trestle?
They carry the pipe and drop the pipe sections in.
A barge?
No, well,
Too shallow? Maybe for
probably the wave action, you couldn't live with a barge. We have to monitor the shoreline for certain bacteria, the indication of fecal matter from mammals, so a part of our monitoring. This part of the presentation, any questions on the process itself?
Just the outfall, the pipe that leaves here and ends up at the end, is it buried?
Here it
Did
is.
you trench the reef to get out there?
Yeah, they had to dig the trench, right? Definitely.
So it's buried.
picture of.
Yeah.
10% of the solids that are finalized in the process So those
Yeah, go
those
ahead.
go off-site?
No, that goes to the, we do, you know, of course, when the aerobic bacteria are busy chewing up the organic waste, they reproduce at roughly 10%, whatever my mass is. If it's 1,000 pounds, they produce 100 pounds of material I got to get rid of. It's a good question, because that I take and I run through a belt press thickener to remove water, and then that's combined with the sludge from the primary clarifiers, and that goes to the anaerobic digesters. Then anaerobic digesters, we remove about, I think, 30% of the volatile material and biologically degradable material. The idea there is you can cut your disposal costs down significantly. And then we go to a screw press to squeeze the water out of it, and thereby allowing us to haul less loads of material out of this plant. We basically dispose of 40 tons of this sludge a week. And that's both the bacteria and the sludge that the primary clarifier removes. And remember the coffee grinds Crisco combo. That's your coffee grinds sent to the anaerobic digester for biological assimilation.
I noticed at the Marine Corps base, they have an area where they discharge the sludge and it dries.
Yep.
And then they scoop it up and take it away.
Yeah.
Where would that process be, or do you not have that process?
We had it.
Oh.
The plant was built with drying beds, and until it was 2019, we kicked on the screw presses, right, Matt? When we did that project in less than a year, because we were under the gun. The city said you got to go to H-Power. It took a lot of Matt's time, because very quickly he had to put together a design team, and we had to select what we wanted to. We'd make a selection between a centrifuge, a belt press, or a screw press, and we chose the latter.
So those anaerobic digesters, is that the same kind of process you make alcohol?
Yeah, fermentation.
Do you guys have a
We don't distill.
yeah.
That's too
You
bad.
just let it evaporate off? Or?
We a little bit different raw material and a little different objective. So our material is
Use it as
not
fuel or
as
something.
easily biodegradable, and it's nowhere near as concentrated.
Okay.
But end products of our fermentation, we do generate methane gas, and we flare that. We looked at, I think we looked 3 times, Matt, or 2 times at using that gas to generate electricity to support the plant. It has yet to pencil out for us. And we do have solar panels to help us keep electrical costs down. We have also have done some changes to our process to reduce energy usage. And I'll talk about that when we're on the tour. We're about
Do you have
to get.
an area where it burns off the methane?
Yes, we have a torch. We have
Do you have a torch? Okay.
the best tiki torch in Hawaii Kai.
Okay.
The trouble is, in the daytime, you really don't see the flames, but it's really pretty in the morning and at night. Yeah,
Okay.
it doesn't burn it that hot.
But it constantly burns, right?
Yeah. We constantly produce gas.
Lee, on this photograph that's up here, there are 2 black circles and 2 white circles. Are they the primary clarifier and the digesters?
Okay. No, but I'll show you. I'll get over there. I'll just. Yeah, I can show you the primary clarifiers are the rectangular tanks here. There's 3 of them. The grit removal is in this area, not well shown in this picture. Primary treatment, then we flow into a channel. That's our Anoxic Zone I talked about. So primary treatment, Anoxic Zone. And then these are the 2 biological reactors. To answer Mac's question, the 2 dark circles are our final clarifiers. They separate the bacteria from the water you're going to dispose of. The 2 white circles are our anaerobic digesters, our fermenters. Yeah, so, and then we're right here to get oriented.
What's that?
We're here in this green roof building. Yep, you're right here. So join me out in the lobby area for a couple minutes, and then we'll start our tour.
Please click to subscribe, and then click to see Part 2, the plant tour.